Okay, I messed up the previous lecture that I was doing, so I'm starting again recording, and I'm going to upload both of them. So the compound that I gave you, what was the, okay, AlHSO43? Was that this? Okay, so now I was calculating the molar mass. So you say you have 1 aluminum, you should multiply this hydrogen here by these 3. So you have basically this 1 by 3. So you have 3 hydrogens, you have 3 sulfur, and you have 12 oxygen, right? And you substitute these numbers. If you go to your periodic table, you see you have 26.98 for aluminum, you have 1.01 for hydrogen. For sulfur, you have 32.06, and then you have 16 for oxygen. So you substitute these numbers here, okay, and calculate this number, whatever it would be grams per mole. So 1 mole of AlHSO43 has this much of grams in it. And to just summarize, I gave you 10 grams of O. You converted grams of O to moles of O by molar mass. You converted moles of oxygen to moles of your compounds by the chemical formula. And you convert moles of your compound to grams of your compound by molar mass, and that would be this number here. Okay, and then you put the numbers in calculator and you find a number, right? And that would be your number A. That would be that mass. And you do the same for B, C, and D and compare them. Whichever is highest is heaviest. Does that make sense? Feel free to go through the problem and then email me if you have any questions. And I'll be available next week at my office too, but since you have like your finals, I didn't schedule traditional office hours, but I'll be most of the time in my office. Just email me if you want to meet with me, so I make sure that at that time that you want to meet, I'll be at my office. So feel free to just schedule tutoring or office hours with me. But as I said, since you have your exams, and I'm not sure exactly when you guys have your exams, I didn't schedule the traditional office hours. Okay, are we good with this type of questions? And if I ask you, I may give you like each of the following compounds have the mass of 100 grams. Which one contains more nitrogen atoms? Okay? So if I ask number of atoms, you should convert them to Avogadro's number, right? Remember? Or I say which of the following contains the most number of atoms, or the most number of molecules. You just have a conversion factor, converting moles to number of atoms or molecules. Yes?
So would you, when it says multiply the mole by oxygen, so you would add the actual, like, the follows number, or would you add the literal molar mass?
Okay, let me write that. Wait, that's a great question. So I say, which of the following has the mass of 100 grams? Which one has the most number of oxygen atoms? Okay, and I give you like H2O or like N2O5 or NO2, or like I say all have the same number of atoms, the same number of oxygen atoms. So what you do, what you want to write, you write question mark that thing. How many number of oxygen atoms equals 100 grams of H2O? Because I said which of the following has the mass of 100 grams. It means that your compound's mass is 100 grams, right? Now, we cannot convert grams to number of atoms. What you do, you convert grams to moles. And this one you do with molar mass, remember? And that would be 1 mole. In this case, it would be H2O, 2 multiplied by 1.01 plus 16. So it would be 18.02, right? That was straightforward, so I just could write it. And then convert in moles of H2O. What do you want? Oxygen. So you should convert moles of H2O to moles of oxygen. What is this ratio? In 1 mole of H2O, you have 1 mole of oxygen, right? Whatever this number here is for oxygen. If I would add hydrogen atoms, it would be 2, okay? And now you can convert moles of oxygen to number of oxygen atoms by Avogadro's number, right? And if I ask you, you're welcome to put everything in a calculator, but if I ask you this type of question, you can just compute this number here, right? And then compare them, because this part is the same for all of them. And if I give you like 100 grams for all of them, this number here is also the same 100 grams. So as long as you have like these coefficients here, for some reason in the updated version of the software, it doesn't have highlighter. So anyway, so this one here, as long as you have these coefficients here and molar mass of your compound, and calculate this ratio for 3 of them, and then whichever is higher, that would be your answer. But I may give different numbers, here. So one of them would be 100 grams, the other would be 52 grams, So you may need to actually consider this number here as well. But this is the procedure that you solve this question. Does that make sense? Okay, so now let me talk about the next type, or like chemical equations and reactions. So if I give you this, I say 2A plus 3B plus C gives 4D. And I tell you 4 moles of A reacts with 10 moles of B and 5 moles of C and generates 1 mole of D. What is the actual yield? What is it? Exactly. Actual yield I should give you. If I don't give you and ask you, if I give you the same question, and I say 4 moles of A reacts with 10 moles of B and 5 moles of C, what is the actual yield? We don't know, right? Because you don't know what was going on when someone was doing this reaction. So actual yield I should give you, and I write that here, 1 mole of D, that is the actual yield. And remember that yield is the amount of product. The amount of product. But for theoretical yield, what you do is that you calculate the amount of your product based on each of your reactants. Okay? After doing the calculation, compare the numbers. Whichever is the smallest is your theoretical yield, and that would be the maximum amount of products that you can make. The reactant that produces the theoretical yield is your limiting reactant. Okay, because I want to solve more problems, I don't go through the pancake example and all that. Just at this point, remember, and if you have any questions about this, just email me so I explain things to you further. So you say how many moles of D is equal to 4 moles of A. And remember, these coefficients are here are your mole to mole conversions. Mole to mole conversions. This is the only time you use them. Here, when you write how many moles of D is equal, you write the actual amount of your reactant, not the coefficients, okay? So you convert, moles of A to moles of D. This one would be your coefficients, okay? So 2 moles of A generates 4 moles of D. Does that make sense? And this answer would be 8 moles of D. Questions? You do the same for 10 moles of B. And 3 moles of B generates 4 moles of D. So 40 divided by 3, what is it, 13.33, right? Moles of D. How about how many moles of D equals 5 moles of C? And I convert. You just read this number here, 1. So what is my theoretical yield? 8 moles of D, the smallest number. Smallest number would be my theoretical yield. What is my limiting reactant? A. Remember the reactant. So if I ask you what is limiting reactant, it would be one of these 3, one of your reactants. The reactant that leads to theoretical yield is your limiting reactant. Does that make sense? Okay. And then I talked about actual yield too. And finally, if I can manage, okay, sometimes it works better than the other times, I don't know why. So percent yield is the smaller number, which is actual yield, divided by theoretical yield, multiplied by 100%. What was my actual yield? What's that? 1 mole of D right here. What was my theoretical yield? Exactly. Multiply by 100%. So that is 100 over 8. That would be 25 over 2, 12.5%. Right? Questions? Is that good? Okay. If that is good, I also write a calculation or reaction that actually has compounds and elements compared to just having A, B, C, or D. So if I tell you, CH4 plus 2O2 gives CO2 plus 2H2O. As I said, in your exam, the reaction that I write for these numerical questions, I balance and I ask balancing equations separately. So if you don't know how to balance, you don't lose points for these questions. But in theory, you should make sure that your equation is balanced. Otherwise, you cannot solve any problem if your equation is not balanced. And I tell you, 25 grams of methane, and I give you methane CH4, reacts with 12 grams of O2 and generates, 5 grams of CO2. What is your percent yield? Okay. So when you have multiple products, any product that I'm talking about, you just consider that to calculate theoretical yield. Does that make sense? So now we're talking about CO2. So what you do, you say how many grams of CO2 equals 25 grams of CH4. How can I convert grams of CH4 to grams of CO2? Can I do that just by one conversion factor? No. So we do grams to moles by molar mass. We do moles to moles by coefficients of the balanced chemical equation or reaction. And you see these two cancel out, these two cancel out. And finally, you convert moles of CO2 to grams of CO2 by molar mass again. Okay? So CH4, if you go to your periodic table, you see this number for H, C, and O. Okay, so CH4 would be 1 carbon plus 4 hydrogens, right? What else do I have? CO2. CO2 would be 1 carbon plus 2 oxygens. So this is 32, would be 44.01 grams per mole. And for this one would be 12.01 plus 4.04. So 16.05. Hopefully I wrote that correctly. Grams per moles. So for CH4, 1 mole of CH4 has this much of mass. 1 mole of CO2 has also this much of mass. And here, what is this ratio here? Exactly, 1 to 1. So you put these numbers in calculator and find the answer. And you do the same for O2 as well. So what you do, you write that how many grams of CO2 equals 12 grams of O2. And then converting grams to moles by molar mass, and then moles of O2 to moles of CO2 with coefficients of the balanced chemical equation, and converting moles of CO2 with grams of CO2. I already wrote this number here. And you also do the calculations here, right? And then you find this number here and that number here. You compare whichever is the smallest is the theoretical yield, okay? So I write here, smaller number would be theoretical yield. Okay, and to find percent yield, here I gave you 5 grams of CO2 for, okay, hand feature, okay. For percent yield, you say percent yield equals actual, remember the numerator should be a smaller number, actual yield divided by theoretical yield multiplied by 100%. So you have 5 grams, that is your actual yield, and then you put theoretical yield here that you find, multiplied by 100%, and that would be your percent yield. And hopefully the numbers that I wrote, I just wrote that randomly. Yeah, they would be hopefully more than 5, yeah. But even if the numbers you calculate and then you see that, I guess I just changed this number to, I don't know, 1. So make sure that that would be lower than your theoretical yield, okay? Does that make sense? But actual yield I give you, so you don't have to worry about that. Any questions? Are we good with this type of questions? Do you have any question from numerical problems or anything in general that you want me to explain first? So you make sure that I go through that before I just talk about electron configuration and all that. We're good with the numerical problems, all the conversions and all that? Okay. The other thing thing that I'm going to ask you in exam is electron configuration. So remember, when filling the orbitals, you start with 1s, and it can have maximum 2 electrons, then 2s, maximum 2 electrons, and then 2p, maximum 6 electrons, 3s, maximum 2 electrons, 3p, maximum 6 electrons, and here you had an exception. You write 3d here, maximum 10 electrons, and then you have 4s, maximum 2 electrons, and 4p, maximum 6 electrons. If you just can write these orders that I wrote here, you can answer the electron configuration questions that I give you in exam. And remember, we fill out the orbitals with electrons from the orbitals that they have lowest energy. So this one has the lowest energy, and the energy increases when we go left to right. So if I tell you which of the following has the highest energy, 4p, 3s, 3p, 2p. 4p has the highest energy. Okay, so one question that I ask you, I say, how many occupied orbitals phosphorus has? And I write random numbers. So for the sake of time, I just answer the question. So you go to the periodic table, find phosphorus, and remember to read the number above it. Most of the time in the problems that we were solving, we read atomic mass, the number that was written below. Here we want number of electrons, which is number of protons, which is atomic number. So what is the atomic number for phosphorus? Can anyone see that? 15, right? Okay, so if you know this order, right, you can just start counting. 2 electrons, 4 electrons, 10 electrons, 12, right? And how many more do I want till I reach 15? 3 more, exactly. 1s2, 2s2, 2p6, 3s2, 3p3. And you can check if you wrote it right or wrong. What group phosphorus is in? 5a. So it has the valence of, it has 5 valence electrons. And then what was valence electrons? You consider the highest and count these electrons, right? It would be 5. So you wrote that correctly. And what is the period phosphorus is located at? 3, right? And then when you look at the periodic table, 1, 2, 3. So you can check in this way to make sure you wrote this electron configuration correctly. And I asked you how many occupied orbitals P has. So remember that your S subshells, they have only one orbital, right? What about P subshell? How many orbitals one, for instance, 2P has? It has 3, so I say 2p, or I guess I write p orbital, or like p subshell rather, subshell has 3 orbitals, and that would be px, py, pz. So you have 1, 2, 3 orbitals. And then 3s, I just talked about, S or S subshell in general, they have only one orbital. What about, 3p? Again, p subshell, it doesn't matter whether it's like 2p, 3p, 4p, p subshell has 3 orbitals. So now let's fill this out. So remember that each orbital can have maximum 2 electrons with opposing spin, Pauli exclusion principle. And Hund's rule, when you want to fill orbitals with similar energy, you fill them singly first, then pair them up, right? And these are 2. 1, 2, 3. And now you count. I'm saying how many occupied orbitals. Phosphorus, and that is phosphorus. Don't confuse that with the other P. Phosphorus has. So you say 1, 2, 3, 4, 5, 6, 7, 8, 9. Does that make sense to everyone? And when I say occupied, I mean they have at least one electron. The ones that are empty, they don't have any electrons, I'm not concerned. But you count 1, 2, 3, 4, 5, 6, 7, 8, 9. Any questions? So I give you this in exam, I say which of the following statement is not correct. Phosphorus has 10 occupied orbitals. And that would be the wrong one. Okay? The other question type that I ask you is that I say, what is the element that has this electron configuration? 1s2, 2s2, 2p6, 3s2, 3p6, 3d3. Can anyone tell me the answer?
Doesn't exist.
Exactly. First, we should fill out 4s. Okay? So these exist, or like if I have the same thing and I write 4s2, that exists. If I write the same thing, I write 4s2, 3d, I don't know, like 3, that exists, okay? But if you don't see 4s being filled before, and I'm asking element, you might have ions that, if I write, for instance, 3d10, you might have an element that lost 2 electrons, an ion. But if I ask you elements, you don't have any element with this electron configuration. And similar type of question, if I ask you the same thing and give you this, 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, and then 4p6, and I say 3f5. What about this one? Any idea?
F is until you get to 4.
What's that?
F is until you get to 4.
Exactly. We don't have 3f. When n equals 1, you have one subshell that is s. When you are in n equal 2, you have 2 subshells. And those are s and p. When n equals 3, you have 3 subshells. And those are S, P, D. So you don't have 3F. You don't have 1P, right? You don't have 2D. Good? Questions? And quickly I go through Lewis structures. So when you want to write dot structures, first of all, dot structure or Lewis structures are really simple models. Even if we have difficulties writing them in theory, they are really simple models. We just put valence electrons around the element. So if I ask you in the exam that Lewis structures are really difficult to draw, that statement would be false. Okay, so to write Lewis structures, you write the atomic symbol, and then you, whatever the number of your valence electrons is, you put dots around the element. So for fluorine, the valence, and don't confuse that with number of electrons. We talk about valence or number of valence electrons. So for fluorine is located in group 7A. It has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. And it's helpful if you put them singly first and then pair them when you write the Lewis structures for molecules specifically. Okay? So if I ask you to write the Lewis structure for H2O, right? What you do individually, just write it for hydrogen first. How many valence electrons hydrogen has? It has only one electron, right? What about oxygen?
6.
Exactly. 1, 2, 3, 4, 5, 6. Okay. And if in the case of H2O, you have 2 H's, right? And then you have 2 oxygen. And try to have the ones that are single kind of in front of the other atom, because 2 electrons between the atoms, we want to form a chemical bond that we denote with dash. So that's why I'm writing this oxygen like this. Okay. So now these two, this oxygen and this hydrogen, they can form a bond, and this hydrogen and this oxygen can form a bond. Okay. And remember, in molecules or molecular compounds, we have covalent bonds. So electrons are being shared between the atoms. So here, if I ask you how many electrons oxygen has in this structure? 8, exactly. It reaches an octet, and you say 1, 2, 3, 4, 5, 6, 7, 8. And you may ask me, wasn't this, electron here, wasn't that for hydrogen? I'm telling yes, but they are sharing this. The same with the other electron here. Hydrogen is sharing that electron and reaching a duet. Remember that for hydrogen, helium, lithium, beryllium, they won't reach. On a helium, it has a duet structure, so it has maximum 2 electrons in its valence. But for the other ones also, they don't reach an octet, because beryllium uses 2 electrons and reaches the electron configuration of the noble gas before it, which is helium. Okay. Another example is how many bonding electrons do you see in the Lewis structure of water? How many bonding electrons do you see? How many exactly? How many, if I ask, bonding electrons would be 4. 1, 2, 3, 4. If I ask how many bonding electron pairs, it would be 2. How many non-bonding electrons do you see?
4.
Exactly, non-bonding would be 4. How many non-bonding pairs? 2. Okay. And just, kind of like review really quick in just like few seconds that I have. You remember gamma rays, they are like the most dangerous to human beings. These are like highest energy. Then you have X-rays. Then you have then you have UV, ultraviolet. Ultraviolet. And you can leave the class if you want. I just want to have the recording. And then violet is like one, side of the spectrum of visible light. So you have visible light here. That here you have violet. And then the other side of the spectrum, you have red. So you have here IR, which is infrared. And then you have microwaves. And then you have radio waves. I cannot write here. Okay. Then you have radio waves. And hopefully you can see that. So radio waves have like the longest wavelength, which corresponds to the lowest energy and lowest frequency. Yeah. Questions? Yes. Yes. I asked you to write the Lewis structure for my Mg became so distorted. MgCl2. What you do, write it for Mg first. What is the valence of Mg? 2, exactly. What is it for chlorine? 7, exactly. 1, 2, 3, 4, 5, 6, 7. Okay. So you have 1 Mg. Just write them individually and then write it for your compound. You have Mg and then 2 Cl atoms, okay? So what happens, Mg loses these electrons, and where do they go? They go to each of these chlorine atoms, right? So when Mg loses the electrons, we just write Mg2 plus to show that Mg lost those electrons. And each of these chlorine atoms, they reach an octet, right? But remember here, chlorine gained 1 electron. So now it has the charge of -1. And then the same thing for the other one. You know, this electron went here. Now this electron goes here. So this chlorine atom also reached an octet. And then you have Cl minus here. So if I ask you, after writing Lewis's structure for MgCl2, how many dots do you see? How many? 16. But if I ask you, how many electron pairs do you see? If I ask pair, you just divide that number by 2. And the same thing for like here. When I